Hello again, welcome to my class. Today is all about the mole. My name is Teacher Hura and the mole is one of my favorite topics. Now, a lot of students will have a problem with this chapter of the mole because they feel like this question right here, what is the mole, is a very difficult one. However, it's very simple. You need to look at the mole as something like counting unit. A counting unit. For example, if you look at a pair means that we have two things. And for instance, we can say a pair of shoes. That means we have two shoes. That means two things. Now, let's look at another example. A dozen. A dozen is another counting unit, which stands for 12 things. Again, it is very simple. If you have a dozen of donuts, it means that you have 12 donuts. Let's look at another example. A tray of eggs. Now, a tray of eggs contains 30 eggs. That means if you go to the shop and ask for a tray of eggs, then you will get 30 eggs. Now, let's get to science now. A mole. Now, you see, one mole of something means that you have 6.023 times 10 to the power 23 things. Now, this is a scientific way of writing a very large number. Now, this large number is this one here. As you can see, there are so many zeros here. And if you were to read this number, it would be a very difficult number to read. It would be something like 602 hexillion 300 pentillion. Now, well, I don't know even if that is correct, but that number is very large. That is why it is simpler just to say 6.023 times 10 to the power 23 things. Now that would mean that we use the mole for chemicals or substances. For example, we can say 1 mole of carbon atoms. That would mean that we have 6.023 times 10 to the power 23 atoms of carbon. So whenever you have that number, we can say it is a mole. So chemists came up with this number, the mole, to help in counting the atoms, elements, and all other things. Now, looking at this, you'll realize that when you're talking about a pair of shoes, that is something you can easily see. If you talk about a dozen of donuts and a tray of eggs, those ones, you are able to see them. But atoms are so tiny. They are so tiny that you cannot see them. So through scientific inquiry and a lot of research, scientists have found a way of counting these little building blocks of everything. So they found out that, let us see, if counting atoms is so difficult with these huge numbers, let us try and group these huge numbers together and have it as a mole. This mole of substances was developed by a scientist known as Avogadro, and that is why this number is usually known as the Avogadros number. So ideally speaking, you can say that 1 mole of a substance contains 6.023 times 10 to the power 23 particles. Now these particles can be atoms, they can be ions, they can be molecules, electrons, or any of these other tiny building blocks of atoms or elements in chemistry. Whenever you're dealing with chemistry, instead of saying a dozen of atoms, we say a mole of atoms, which stands for 6.023 times 10 to the power 23 particles. That could be atoms, ions, molecules, electrons, etc. All right, now let's bring this to perspective. I'll use a little experiment for this. You can ask yourself, how much is a ton of coins? Now, for us to be able to do this, we need to measure the mass of each different kind of coins, and then we can be able to convert it into a ton and see how many or how much that will be. So I'll have my scale right here, and of course turn it on and measure the masses of each of these coins right here. So let us start with the 5 shilling coin. So the 5 shilling coin, you put it there. and you get right there, the mass is 4 grams. So I'll note it down. Just move this aside and note it down as 4 grams. Then of course I go and measure the same with the 10 shilling coin, and I see that now that is 5 grams. So I put it down here, 5 grams. And finally, the 20 shilling coin is 9 grams. So that is 9 grams. You should be right here. Well, that's it. So you can see that now we have the mass of each of these different kind of coins. So if you want to know how much a ton of coins is worth, it's just to see if one coin is weighing 4 grams, how about a ton of coins? And so on and so forth for all these others. So let's just have some few questions that are going to help us to see what it means by converting these masses and trying to find out how much they can be. All right, let's get to the first question. So imagine you are a bank teller and this supermarket representative has come and said he needs 15,000 shillings in 5 shilling coins because they use it to give up change and balance for the customers. So how many coins will you give them? That will be easy. You will just do like this. You will say, okay, I know that I need 15,000 worth of money. So, and each coin is 5 shillings. So now I divide that by 5 to get how many coins I would give. So that one would be very easy. You just divide this and you cross this one by 1, this one by 3, and of course it remains 3,000. So you will need to give 3,000 coins. Now, you can imagine now that you have all the 5 shilling coins and you have to start counting from 1 up to 3,000. It will take you quite a while. But if you now have this little trick up your sleeve, you'll find that if one coin is 4 grams, you'll ask yourself, so how much weight will 3,000 coins have? So you'll have it like one coin has a mass of only 4 grams. How about 3,000 coins? So this one here, with the simple arithmetic and basic mathematics, you'll know that you're supposed to cross multiply, and it would be 3,000 multiplied by 4 divided by 1. This gives us, well, 12,000 coins. Oh, not coins, but grams now. You have 12,000 grams of 5 shilling coins. So all you need to do is to get your scale, just like I did last time, and then you put in 12,000 grams of coins, and that's it. Some easy. Within a short time, you have 3,000 coins of 5 shilling coins. So you can see it is an easier way of trying to count so many things within a very short time. All right, so let's go to the second one. The second one is, again, the supermarket attendant comes and says, I need 180,000 shillings in 20 shilling coins. The procedure would be the same. You would come and check your 20 shilling coin is 9 grams. Now, since that is just 9 grams for one coin, you'll ask yourself, how many coins will I need? So the first thing you do is to get the 180,000 shillings and divide that by 20 in order to get the value, the number of coins that you need. So of course, that one will just calculate like this, by 21, and this one is going to be by 20. Of course, this is going to be 90, and then this one is going to be 0, 0. Good. So now that is going to be your answer. So 9,000. So you have 9,000 coins. So now you'll ask yourself, how will I start counting all these 9,020 shilling coins? So it is very easy. Again, you use the mass. As we said, one coin has a mass of only 9 grams. So you ask yourself, how about 9,000 coins? What would be the mass for this? So once again, we will just do a simple cross multiplication and then we get the answer. So it will be 9,000 multiplied by 9, and of course you divide by 1, and this is going to give us the mass of the 20 shilling coins that you would need. So of course this is going to give you 81,000 grams. So all you need to do is get into a scale and measure 81,000 grams, and you're going to give them that worth of coins. Quite heavy for that, because if you convert this into kilos, it's about 81 kilos. So it will be quite a heavy amount of coins. So now let us ask ourselves for the last question. How much is 1 ton of 10 shilling coins? So now again, we'll come back to our table here, and we'll see that 1 coin of 10 shillings is 5 grams. So how about 1 ton? So this is going to be simple. So you'll say again, just like we did previously, we have 1 coin of 10 shillings is only 5 grams. And the question is now, how many coins will be 1 ton? Now 1 ton is 1 million grams. So I'll convert this into grams and I'll have 1 million grams. So once again, it's a simple cross multiplication. So you cross this one out and you'll see that it is 1 million multiplied by 1 and divide by 5. So this gives you the number of coins that you would need to get to 1 ton of 10 shilling coins. So of course you'll cross this one out by 1, this one goes there twice, and then you'll have 1, 2, 3, 4, 5. So you cross that one out like that. So you'll have 200,000 coins. So now that you have 200,000 coins, the question is, how much money is this? So if each coin, 1 coin, is worth 10 shillings, so the question is, how about 200,000 of them? Of course, again, we'll do a simple cross multiplication. And you'll find that that one is 200,000 multiplied by 10 divided by 1, giving us 2 million. So this is worth 2 million shillings. So a ton of 10 shilling coins is worth 2 million shillings. So that is the little experiment. Now I'm going to relate these back into the atoms, because the same concept of trying to convert from grams to coins and even to the worth amount of that coins is the same concept that you're going to use in the mole in converting from the number of atoms to grams and so on. All right, now to recap, we'll say that the mole is the amount of substance that contains 6.023 times 10 to the power 23 particles. Now, what that number is, it's also called the Avogadros number. Now, the Avogadros number is named after the scientist who came about this number. And so it's called the Avogadros number with an abbreviation of letter L. Now, this number is going to be very important because it is going to show us exactly how to calculate different mass and moles and number of atoms in the questions. So I like to just summarize this in form of a formula, whereby you'll start by saying now it can be written as 1 mole contains 6.023 times 10 to the power of 23 particles. And now you remember that these particles could be either atoms, they could be ions, they could be electrons, or molecules, etc. So these building blocks in chemistry. Now, since this is our first formula, I'm going to show you how now to use this and calculate a few things. But before we move on, I'll need to introduce a new concept called molar mass that is going to help us to calculate even now in terms of grams. You can remember in our experiment, we talked about the mass of coins. Now we want to know the mass of 1 mole of different kinds of atoms. So here we go. We say the molar mass means that the mass of 1 mole of a substance. Now this molar mass is closely related to what is known as the relative atomic mass, usually in chemistry abbreviated as RAM. Now, for example, you'll find that the relative atomic mass of sodium is 23. This number 23 can be found in the periodic table, and it is the mass, it is the number of sodium, the number of the atomic mass of sodium. So you can find that the molar mass of sodium is 23 grams. So if you just take the value of the relative atomic mass of sodium and add grams to it, it means that now 1 mole of sodium will have a mass of 23. Now let's look at another one. The relative atomic mass of sulfur is 32. If you take 32 grams of sulfur, then you have 1 mole of sulfur, because that is the molar mass, the mass of 1 mole of a substance. Once again, if you go and say the relative atomic mass of carbon is 12, therefore the molar mass of carbon is, yes, I'm sure it's obvious, you've already said it, the answer is 12. So you can see, you can write it down here as 12 grams. So long as I have these grams here, I know that is the molar mass. Now I'm going to relate this in form of another formula, the second one, that is going to be very important for us. So you'll start off by saying, if 1 mole of any substance has 6.023 times 10 to the power 23 particles, then we can also have another formula from the molar mass. We know that the mass of 1 mole of any substance is also equivalent to the relative atomic mass in grams. Now, let me give you an example. So we've just said that 1 mole of sodium has a mass of 23 grams. So this is what it means, the relative atomic mass value in grams. Do you remember for carbon, 1 mole of carbon will have a mass of, yes, I think you guessed it right, so it's going to be 12 grams. Now 1 mole of sulfur will be 32 grams. So you can see now all these sentences, they come out and they bring out the relationship between the mole and the relative atomic mass. So that means that if I have the relative atomic mass value in grams of any substance, that one will be equal to the 6.023 times 10 to the power 23 particles. You can see that. Now, looking at this, you'll realize that this statement here, I can call it A, and this statement I can call it B, and this one I can call it C. So just ask yourself, if A is equal to B, then of course, and you say B is equal to C, it follows that A is equal to C. So that is the simple way of trying to relate these three things. So the two important statements that I don't want you to forget are these two. So you realize that you can say that 1 mole of a substance contains 6.023 times 10 to the power 23. 1 mole of a substance is also equivalent to the relative atomic mass value in grams. All right, so just like in the coins experiment, I want us to look at a few questions that are going to show us how to use these formulas that you've learned. So the first question is calculate the number of moles in the number of atoms in 0.5 moles of sodium. So here you will start by saying that the statement we had is that 1 mole of sodium, of course, contains the 6.023 times 10 to the power 23 atoms. You remember those particles can be atoms, they can be molecules. But now here, since the question is dealing with atoms, we shall relate with the atoms. So how about 0.5 moles of sodium? So you'll realize again, just like we did in the coin experiment, you're going to cross multiply. So here we'll have our 0.5 multiplied by 6.023 times 10 to the power 23, and of course divided by 1. So this gives our answer in atoms. So once you calculate that, what do you get? You'll get a 3.0115 times 10 to the power of 23 atoms. So you'll realize that this is the number of sodium atoms in 0.5 moles. Now let's look at another example. So in this second example, you're supposed to calculate the number of atoms in 24 grams of carbon. So once again, just remember that we had our formula of 1 mole contains 6.023 times 10 to the power of 23 atoms. However, now we don't have a mole, we have the value in grams. Now right here in brackets, we have what is the relative atomic mass of carbon, which is 12. Now since that is what we have, we can now calculate using the relative atomic mass. And remember that the relative atomic mass value in grams is also equivalent to the 6.023 multiplied by 10 to the power of 23 atoms. So now this statement, the second statement, is the one that you're going to use for this calculation. At least it is the combination or the first statement, A and B, I had talked about earlier. You remember that 1 mole is 6.023 times 10 to the power 23 particles, and 1 mole is also relative atomic mass value in grams. So that it follows this third statement that the relative atomic mass value in grams is also equivalent to the Avogadros number. So now you'll say that 12 grams of carbon, of course, contain 6.023 times 10 to the power of 23 atoms. So the question is, how about the 24 grams? So here you'll just write it down here, 24 grams of carbon. And just like we did before, again, it's another cross multiplication. So you cross multiply and you have 24 multiplied by 6.023 multiplied by 10 to the power of 23. Divide that by 12. So if you simplify this, you end up with this times 2. And this gives us a 1.2046 multiplied by the 10 to the power of now 24 atoms. So this is a very huge number, but at least now you can see that it is very easy. All you need to remember is that 1 mole of a substance has 6.023 times 10 to the power of 23 particles. And it also follows that 1 mole of any substance is equivalent to the relative atomic mass value in grams. This one is what we called the molar mass. And then finally, you can know that the relative atomic mass value in grams is equivalent to now the 6.023 times 10 to the power 23 particles. So that is the simple way of calculating the mole, and you will find that it is the basic or the first step in you calculating any kind of mole question. Now, if you've learned something today, please give this video a like, and if you've not yet subscribed, subscribe to my channel so that you don't miss out on any other insights on different concepts in chemistry. See you next time.